Calling DALL-E 3 from Python is one line of code. Building a production image generation service around it is not. Today we dissect a realistic reference architecture for generating images with DALL-E 3 on Azure OpenAI. The components, how a request flows through it, where it breaks, and the trade-offs an architect actually weighs. By the end, you'll know why you don't just return the model's URL to the browser, how to survive content filters and rate limits, and where to spend your reliability budget. Let's get into the diagram. Here's the wiring. A client sends a prompt to your backend running on Azure Container Apps. The backend authenticates with a managed identity, pulls no secrets from disk, and calls the Azure OpenAI DALL-E 3 deployment. The model returns either a temporary image URL or base 64 bytes. Your backend writes those bytes to Blob Storage, then hands the client a time-limited shared access signature, an SAS URL, pointing at your own storage. Notice the backend sits in the middle of every hop. That's deliberate. It's where you enforce auth, retries, content moderation, and logging. The model is just one node in the flow, not the front door. Here's the core call with the Python SDK. You point the client at your Azure OpenAI endpoint. Use a token from your managed identity instead of an API key, and target your DALL-E 3 deployment by name, not the model name. Two parameters matter most. Set response format to base 64 JSON so you receive the actual bytes, not a URL that expires in about an hour. And set size to one of the supported values, 1024 by 1024, 1792 by 1024, or 1024 by 1792. DALL-E 3 also generates exactly one image per call, so n is always 1. The most common mistake is returning the model's image URL straight to the browser. That URL is hosted by Azure OpenAI and expires roughly within the hour, so any image saved, shared, or rendered later just breaks. So your backend takes the base 64 bytes, writes them to Blob Storage, and issues your own shared access signature URL with a lifetime you control. This also gives you durable storage for audit, regeneration, and cost analytics. A practical rule of thumb: store the prompt, the revised prompt DALL-E 3 returns, and the blob path together, so you can trace any image back to exactly what was asked. 3 failures will hit you in production. First, content filtering. DALL-E 3 rejects prompts that trip its safety system, returning an error, not an image. Your backend must catch that and surface a clean message, not a 500. Second, rate limits and quota. Image generation is billed and throttled per minute, and DALL-E 3 is slower than text, often several seconds per image. Expect 429 responses under load and implement exponential backoff. Third, latency-driven timeouts. Because a single image can take 5 to 15 seconds, a synchronous HTTP request risks gateway timeouts. Treat slowness as the normal case, not the exception. This is the central trade-off. The simple synchronous design has the client wait for the whole call. It's easy to build and fine for low-traffic internal tools. But under real load, those multi-second waits tie up connections and timeout. The async design has the backend drop the job onto a queue like Azure Service Bus, return a job ID immediately, and let a worker process the generation and write to Blob. The client polls or gets notified when done. You pay in complexity, but you decouple bursty demand from your fixed DALL-E 3 quota. My rule of thumb: go async the moment image generation is user-facing at scale. 2 final pieces lock this down. For identity, prefer a managed identity over API keys so there are no secrets in your config, and keep any remaining configuration in Key Vault. For scale, remember DALL-E 3 has regional availability and per deployment quota that you must request and monitor. Don't assume your region has capacity. Check the model availability table and your quota in the Azure portal. Because these limits, prices, and supported sizes change, verify the current Azure OpenAI documentation before you commit a design or quote a cost. Put quota and latency metrics on a dashboard from day one. So here's the shape of a solid DALL-E 3 design on Azure OpenAI. Your backend mediates every call, authenticates with a managed identity, requests base 64 bytes, and persists them to Blob Storage with your own shared access signature URLs. You handle content filtering, 429 backoff, and multi-second latency as normal cases, and you go asynchronous with a queue once you're user-facing at scale. The one concrete takeaway: never return the model's temporary URL to your client. Decode the bytes, store them, and serve your own link. Do that, and everything else in this architecture becomes easier to build. Check the current docs for sizes, quota, and pricing. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.